So the communicator we got from our elves yesterday has a problem, which is that it's eaten too much data, and all that data has filled up its little hard drive. And we don't really know yet how full the hard drive is. We just know that we need to clear out some space to download an update so that it will work better. So our goal is to figure out how much space we have to delete and to find the smallest directory we can delete to satisfy that requirement. And that's part two, but part one is kind of part of that. And our input is a just list of commands and outputs that we ran. The commands can either be cd to root the parent directory or the dir name, or they can be a ls, the results of which will either be a dir, which we can ignore because eventually we'll cd to that dir, and I'll explain why later, or a file with the size as well. And so the first challenge will be constructing a file tree for this for this phone's like operating system. And that file tree will start at the root, obviously, and then there will be both directories and files, which is kind of the result of our IO stuff. And we need to associate files with a parent directory and sizes with those files. So to start, we will write an input parser. And what this input parser will do is read through line by line and determine what kind of command is being run. And there's a few useful things we can take advantage of here. One is that our commands will all start with a dollar sign, and then spaces are used to separate the different parts of the command. And so we know that $L or $space L is going to be a no op because the ls, that doesn't tell us anything. That's a command that we quote unquote ran. And the same is true for a dir. If the line starts with dir, we can ignore the rest of the line because eventually we'll cd into that dir, and that's when we should take care of adding parents and children and stuff to the directory. And so from there, we can start to look at CD. So obviously, if CD is slash, the target is slash, then we should return to the root. Otherwise, if it's dot dot, we should go to wherever we are right now. We should go to that thing's parent. And then otherwise, this is kind of where a lot of the work happens. If the target doesn't exist, the target directory, it doesn't exist in our sort of model, we have to create it, and then we have to change our current directory to that thing we just created. We always have to go to the target. And I forgot to include here a step where if if the line contains numbers, if the line starts with a number, then we need to create a file which is a child of our current directory and associate the size with it, because that's what we'll use. At the end of the day, all of the size in this problem comes from the files. And so we need to read those in and add the size where it's relevant. And so I hear you thinking to yourself, go to and parent and child, how are we going to represent all these things? And this is, we're going to use a few objects. So the first object is going to be a directory object, which is sort of how we will build our tree. It's going to have a parent so that we can cd dot dot. It's going to have children so that we know what to count for this directory's size. And then it will have a method to calculate its size. And in our case, the method will be, we'll use a kind of recursive thing where we'll just keep calling the size method of our children directories until we're just calling it on size of files. And files themselves are much simpler. They only store their parent and their size. And honestly, they probably don't need to store their parent, but they do anyway. And then finally, the way we'll kind of keep track of where we are and that kind of thing, like what is our current directory and blah, 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 is a terminal object. And I'm also going to use the terminal object to keep track of reading lines and things just because it's easy. So this will store our current working directory, and it's also going to do something a little bit cheeky, which is store a list of all the directories. And this is because even though it's, we internally to the objects, we have a representation of their parents and children, so we could use that to navigate to find all the directories. It's easier later when we need to locate or iterate over all directories to just have those available to us in a list. And it doesn't matter anyway, because they're all referenced to the same object. And then finally, yeah, it's like I said, it's going to have methods to create, to parse all the commands and create directories and files. And then, yep, let's go ahead and fix the color there. Awesome, thank you. And so that is kind of the idea behind my solution for today's puzzle. And I've linked my GitHub in the description if you want to see the actual code. And let me know what you think of this new format as well. Okay, thanks.